Hello everyone. Today I'm here to give you some basic concept on immunology, so that the student who are new can understand it easily. Now here I have given some references from which I made this slide from Cubis and Royce. Now let's start. Now, immunity. What do you mean by immunity? It's simply the state or quality of being resistance to a pathogen either by the previous exposure or as an inherited trait. That is known as immunity. Now, next one is immunology. That is a branch of what? Let's say medical microbiology, branch of science. Let's say. Now, study of immune system and its constitution. That is what known as immunology. Now, two basic component of overall immunity. That is the recognition of an pathogen and response against that pathogen by the various defensive cells, let's say, of our body. Now let's look at history. The Edward Jenner, okay, in 1796 AD, the cowpox vaccination induced protection against the smallpox. At the time, I think the smallpox was epidemic, and that's why they cannot control the smallpox, and the Edward Jenner used the cowpox vaccination. Now Louis Pasteur, 1880s, developed vaccine against cholera in chickens and against rabies in human. Waring and Kitasato, 1890, they identified the antibodies in serum was responsible for the neutralization of the pathogen. Now, who is the father of immunity? Do you know or not? Father of immunology. He is Edward Jenner. You can look at this diagram. Look at him. The next one. The type of immunity. There are mainly two types of immunity: innate and adaptive immunity. Adaptive immunity. These are acquired during a lifetime, and these are specific to certain pathogen. Now they are lifelong protective immunity to reinfection with the same pathogen. The next one is innate immunity. That is inherent immunity that is present by birth, like our mucosal membrane, yes, the skin, and innate immunity are first line and second line of defense mechanism. Later on, we'll read in details. They are non-specific. Yes, they respond, but they are non-specific. They cannot. They do not know either that is virus, that is bacteria. But just what do they know is they have to destroy that foreign pathogen to save our body. That innate immunity that is responsible for the initial response to pathogen. Okay, now basic term. Look at here. Now antigen, antibodies, serum, leukocyte, lymphocytes. Now what are antigens? So antigens are what? Antigens are the foreign substance that elicit immune response. So that might be the bacteria, that might be virus, that might be some fungi. Okay, not only those bacteria, virus. Let's say those cell wall of the bacteria, that capsid of the virus, that act as an antigen. Any foreign substance that do not belong to our body, these are considered as antigen, and which has capacity to elicit immune responses. Okay. Now next one is antibody. Antibody are what? They are the protein produced to combat antigen. Yes, antibodies, they recognize antigen, and then after what they present is to present antigen to macrophage, either dendritic cell, either natural killer cells. Okay, so that they can destroy those antigens, I mean pathogens. Now next one is serum. Fluid component of blood that is devoid of clotting factor, that is serum. Okay, we can get the serum by using centrifugation. Now next one is leukocytes. Okay, that include all the white blood cells like macrophages, B cells, T cells. These are known as leukocytes, mainly B cells and T cells. Okay, now look at your lymphocytes, and so the subset of leukocyte and include only B and T cells. These are known as what? Lymphocytes. Now, okay, infectious diseases are caused by the pathogen. Yes, mainly these are parasite, fungi, bacteria, viruses, and antibodies are produced by the body against this particular pathogen. Antibodies, they are produced by either B cells or T cells. Now, this production of antibodies is known as specific immune response, so that they in that case they can recognize antigen. And this type of immune response is known as adaptive immunity. Now, body has its inbuilt immune response. This type of immune response is known as innate immunity that I have previously discussed, and that is non-specific immune response, innate immunity. Okay. Now, leukocytes are white blood cells that have an active role in both innate and adaptive immune response. Leukocytes that like macrophages and like the dendritic that are involved in what innate immune response. And next one is for adaptive T cells and B cells mainly. Look at here, innate immunity, granulocytes like the neutrophils, eosinophils, basophils. Let me read that and its morphology. And macrophages, they are responsible for innate immunity. Why? Lymphocyte, T and B lymphocyte mainly responsible for adaptive immunity. They are specific to certain pathogens or certain viruses. Now, RBC, platelets, WBC all derive from same progenitor, hematopoietic stem cells in a bone marrow. This hematopoietic stem cell that has capacity to divide into any kind of immune cell. Okay. Now, if you don't know about stem cells, please you can look for next video. You can just search on the website for about stem cell. That is very important. You must need to know what is stem cell. Okay. Now, initially these stem cells give rise to stem cells of more or limited potential, which are the immediate progenitor of RBCs, platelets, and two main categories of WBC. First one is the myeloid progenitor, and the next one is the lymphoid progenitor. Now, myeloid progenitor, which is the precursor of the granulocyte, macrophages, platelets, erythrocyte, and mast cells. Next one, lymphoid progenitor, which is a precursor of the B and T cells. Now, look at this diagram. The bone marrow. There is given in bone marrow there is formation what? Pluripotent hematopoietic stem cells. These stem cells has a very large scope in near future. If you don't know about stem cell, please research or build career in this stem cell. Then you might go very high. And look at this bone marrow. Common lymphoid progenitor from is different kind of cell that derive B cells, T cells, natural killer cells. Now look at your B cells having antibody, T cells, and they just transfer to lymph nodes. Natural killer cells. Now look at here. Effector natural killers showing the granules, look activated and NK cells, activated T cells, the plasma cells releasing antibody. Now look at here. From here, common myeloid progenitor, the granulocytes. And why do I get granulocytes? Because of presence of granules. Look at here, neutrophils, eosinophils, basophils. All these contain different kind of granules. Look at here, and these from this leukocyte, the mast cells and macrophages are derived. And again, look at megakaryocyte. Okay, same. Look at here, white blood cells, and these are erythroblasts. These are RBC, okay, red blood cells. These both white blood cell and RBC, they derive from the pluripotent hematopoietic stem cell, okay, through the process of cell differentiation. You must know the term cell differentiation, the conversion of one cell into next cell. Only stem cell can have capacity to go into the process of cell differentiation and form new cell. But they this erythrocyte, or let's say this platelet, they cannot go back and again become this hematopoietic stem cell. Only they are irreversible. So, okay, now look at here. Just need to understand. Look at here. These platelets, RBC, WBC, they all derive from the pluripotent hematopoietic stem cells. Now, this is a 3D diagram to make you clear. Look at this bone marrow stem cell, myeloid precursor, lymphoid precursor, lymphoid progenitor. From its different kind of cell derived, these are memory cell, plasma cell, T and B cells. If you look at it, and from this myeloid precursor, look at mast cell, polymorphonuclear leukocyte, monocyte, macrophages. And from this polymorphonuclear leukocyte, different neutrophils and neutrophils, let's say eosinophils, they will develop. And look at B cells, they have memory cells. Now, granulocytes are polymorphonuclear leukocyte. They contain densely staining granules in the cytoplasm, shortly producing a very large number during the immune response, and classified in three types based on the cellular morphology and the cytoplasmic staining characteristic. The first one, let's say neutrophil, they are present in high amount during the fever or bacterial infection, and they have multi-lobe nucleus, and cytoplasm stains with both acid and basic dyes. Most numerous and important in the innate immunity against bacterial invasion. Next one is eosinophils, that contribute to 1 to 3% of total WBC and has bilobe nucleus. And cytoplasm stained with acid dye, eosin red, hence its name is given eosinophils. are effective against the parasitic invasion. In parasitic infection, the number of eosinophil will be increased. You can look at complete blood clot in that laboratory diagnosis. If eosinophils number are increased than normal, then you can see parasitic infection, or there may be parasitic infection. If the number of let's say neutrophils are very quite high, then we can predict bacterial infection. And look at this basophils, and it has a lobe nucleus. I will show you in diagram next slide. Cytoplasm is stained with basic dimethylene blue. Both neutrophils and eosinophils are phagocytic, whereas basophils are not. Eosinophil and neutrophil, they are phagocytic, mean they engulf different kind of pathogenic cells, let's say. And why do you think that granulocyte, also known as polymorphonuclear leukocyte? Why? Because look at here, polymorphonuclear is actually multiple lobe in a nucleus. That's why they are known as polymorphonuclear leukocytes. Look at this neutrophil. The second one is eosinophil, and this third one, look at this basophil. Yes, look at bilobe nucleus. That is in what? Eosinophil. Multiple lobe nucleus in neutrophil. It's multiple lobe nucleus. Now look, glycogen, secondary glandular, primary. Look at it, phagosome. Different kind of structure. These are present what in them, what for the neutralization of those antigens. Now macrophages are one of the three types of phagocytic in the immune system. And now what may be three type of phagocytic cells? Okay, now this you can comment, or you can comment in video. What are two types? If you don't know, it doesn't matter. Now, are the mature form of monocyte. From monocyte, when become mature, that form macrophages are distributed all over the body. Some take up residue in particle tissue and become fixed macrophages. Others remain motile. Motile means they are able to move from one place to another in a source of what? Antigens, let's say pathogens, let's say bacteria, virus. They have to neutralize. They have to roam here and there because they are what? Part of immune system. And are called free or wandering macrophages. Yes. Now, free macrophages travel by the amoeboid movement. Like amoeboid movement means the amoeba move by some kind of let's say some kind of gestures. That same way, macrophage also move. Now, this is a figure of macrophage and monocyte. You can look at. If a mast cell, the precursor not clearly defined, mainly reside near the small blood vessel mast cells. Okay, and they have role in allergic response and protection of a mucosal surface against the pathogen. Mast cell, if they just come in contact with certain, let's say antigen, certain pathogen, they just release histamine. This help in the cell signaling, and just they by releasing histamine, they will attract neutrophil basophils towards them. And then the next one is lymphoid progenitor. Okay, lymphoid progenitor. This one responsible for adaptive immunity. Okay, they develop later on different stages of our life. Now they give rise to natural killer cells and B and T lymphocyte. Now look at natural killer cells. Yes, are the component of innate immunity. Circulate in the blood as a large lymphocyte with distinctive granules. Don't confuse with innate and adaptive immunity. Yes, though natural killer is from the lymphoid progenitor that play a role in innate immunity. Why? It is the component of innate immunity? Because this natural killer cell do not recognize any kind of antigen that behave in the same way. Yes, this natural killer cell will neutralize, but in second attack, that natural killer cell may not know that previously we have been exposed to the same kind of antigen. But this B and T lymphocyte, they do have memory cells so that they can recognize easily, and in second exposure to same viral infection, they will neutralize very soon because of presence of memory cell. Now look at these natural killer cells. They circulate in blood as a large lymphocyte with distinctive granules and constitute 5 to 10% of lymphocyte in human peripheral blood vessels, like say. Now they lack antigen-specific receptor and kill and recognize abnormal cells. Okay, if there are some abnormal body cells, then they natural killer cells will kill them. Now next lymphocytes. Okay, now B lymphocyte and T lymphocyte. B lymphocyte originate and mature in bone marrow, as you know. Yes. Now, when activated, differentiate into plasma cells that secrete antibodies and memory cell. Now, next one, origin in bone marrow, T lymphocyte, but mature in thymus gland. We can body, that is structure known as